just start lesson 2, introduction to design and strain 1 and 2. And as you can see, design is a very creative process, and in mechanics of material and other upper class, when we do the design, we want to know the difference between analysis and design. What is the difference? And let me start write some note about the analysis and design for this lesson. So analysis and design. And for engineer, we need both. So let's talk about the analysis. So analysis is mean we predict behavior of the existing structure. Behavior. So someone already designed, we want to see what is the behavior in terms of stress, deformation, deflection, etc. So predict the behavior of existing, that is a key, existing structure. So give you an example. Few years ago, a pedestrian bridge in FIU, Florida International University, collapsed that killed 6 people. And people after collapse, different engineer, National Transportation Safety Board go to review what were the design, whether it meet the standard, etc. So that is analysis. They predict, they want to assess the behavior of the structure that already designed. So why that lead to the collapse of the bridge? So that basically the analysis of the structure. And then the design. So basically the engineer that designed that pedestrian bridge originally, and in this case we have a design. So here it's sitting, something already have. So in this case, it will be for design, it create a new structure. Create a new structure to meet a need. For example, to meet the pedestrian student cross the busy street near FIU campus for the walkway bridge that I just mentioned earlier. So that key point here, create a new structure that we call design. Analysis for the existing structure, the difference between the two. So either analysis of design, we have a few terminology that I want to go through. So let's talk about terminology. A few terminology. The first one is the actual level. So the actual, what is actual? So basically the current existing level of the load, stress, etc. So the current existing levels of load, stress, deformation, etc. And for example, the pedestrian bridge, that is the weight of the pedestrian bridge. Also, the people walking through that bridge, all of that is the actual load or stress have it on that structure, that called actual. The second terminology, it called allowable. So allowable, and you already watched the worksheet 2A0. they also give you the maximum allowable tensile stress of 75 ksi. So basically that allowable we're talking about in here. So that allowable is mean that the maximum permissible level, maximum permissible level of load, stress, deformation, deflection, etc. Maximum permissible level of load, stress, deformation, deflection, etc. That is allowable. And then the last one is the failure. The failure, what does that mean? It's with the level of load, stress, etc., where the structure no longer perform, where structure no longer perform. At an extreme example is the failure, basically the pedestrian bridge at FIU collapsed a few years ago. So that as you can see the load, that is the failure loss during the construction. So that the actual allowable and failure level terminology that we have. And then the next term is also very important that we want to get through, that is the factor of safety. And I think you already consider that and have heard that in our real life. Factor of safety. Life so much uncertainty, so we need to consider the factor of safety in our design as an engineer. So as you can see, for example, the FIU pedestrian bridge, the factor of safety during construction, there are some uncertainty. For example, the crack occur, and then some corrective actions, it may exaggerate the failure of the bridge. So something like that we need to consider before we really start build that bridge. It means during the design process, consider the factor of safety. So by definition, the factor of safety is scaling of the failure level, the scaling of the failure level as mentioned earlier, to account for the uncertainty about first the material you design still, but different time of material we don't know what the quality based on the provider, same as the one that you intend to design. So it's the material uncertainty, it may not perform to what we expect. The design uncertainty in design, the costs, because the cost may change, and you can experience what happened during the COVID-19. Some going down like the gasoline, some go up, the price, toilet paper, etc. The number of load, uncertainty in the number of load, just like whether the design of the pedestrian bridge account for the load that may happen in the construction process, just like the pedestrian bridge at FIU. Loading time, And then it's the failure consequences. It also very important here. Failure consequences. Quite important. And you can see if you do the design, your engineering mechanics project, the bridge project 2, if it fails, it's not as much consequence as the pedestrian bridge in FIU. When it fails, it have many casualty, fatal accident, etc. So that the consequence, that's why we need to put more factor of safety in that when the consequence is so high. And of course, there are many other factors that we need to take a look. So that is the factor of safety. So as the engineer, we need to be able to take a look on of that factor when you decide what should be the factor of safety in the structure that we design. So from that, how can we determine the factor of safety? Basically, the factor of safety, let me call that FS, factor of safety. So in this case, the factor of safety Fs is equal to, you can see scaling of the failure level. So it go less than the failure. So it will have the failure level divided by the allowable level. And those are the level that we define in the terminology above. What is the failure? When it no longer perform, the structure no longer perform. Allowable, maximum permissible level of the load, stress, etc. And the ratio of that is basically the factor of safety. So let's box that equation when determining the factor of safety. So from that, we in the study guide of this lesson, we have two types of the design, two concept, two method of design. Design for ultimate, we call that the design in that case is the ultimate stress design, and the second is allowable stress design. And in our class, we use that variation of the allowable stress design. So if you get to the study guide of today's lesson, you can see what are the difference between the two. So from that, we can have the general design equation. General design equation. And that applies for on the design class, we have it in here. So equation in this case is going to be the actual level. Actual level. What is actual level? We just mentioned earlier in the terminology. So basically the current existing level of load, stress, etc. And this have to be less than or equal to the allowable level. The actual on-way have to less than or equal to the allowable level. If it exceeds, the structure may be in jeopardy. So this one is, I can see, the most simple, but that is the most important equation for today class. That is the general design equation. Actual level is less than allowable level. So that the general design equation. So with that, we move on to practice worksheet 2A and 2B and 2C. And I suggest you to practice that before we move on to the next topic for today's lesson. That is the normal strains, shear strains.